Doc, what are you doing? Huh, bud? Good boy. Doc, what are you doing? You trying to scratch your neck on that? Come on, man. What are you doing over there? Are you guarding us? Huh? Are you laying around? Which one? Okay, so over the last few days, I was able to clear out the pole barn here, get everything cleaned up, looking good, and I actually built this 5th brooder box. I apologize for not making a video on it. I just haven't had the time. It's been very, very busy for me. So we made this 5th brooder box to accommodate the 325 chicks that we have coming in on September the 14th. So that gives us a total of 5 brooder boxes here. The lights are off in here, but you can see 4 and then a 5th one here. We also have some of our chicken processing equipment staged and the footprint laid out. Leslie ordered these rubber mats to stand on for processing. And we've got the tank up for rinsing and ice baths. The drying rack here. And the chicken picker. Propane tank and scalder. This is a rotary scalder here. And then we have the kill cones here. So basically what my project is today is to run electricity to the chicken processing equipment behind me. So I went to the store yesterday, I picked out everything that I need. I'm going to run 2 20-amp circuits. I was able to pick up 7 sticks of this 3/4 inch rigid PVC conduit. I was able to pick up ground fault circuit interrupters, GFCI switches, because I'll be within 6 feet of a water source, and this is per the National Electric Code. I was also able to pick up weatherproof covers because we're in wet and damp conditions. And then of course I got all of my male adapters, 3/4 inch with lock nut and a bushing for the panel, which I believe is also code. And then I got single hole 3/4 inch straps. The straps per code for 3/4 inch conduit is every 3 feet. So basically what I need to do is run electrical receptacles, 2 20-amp circuits in a single raceway so that I can power the vacuum sealer behind me here, the chicken scalder over here, which you already saw, the scalder and the propane tank. The power is I believe it's 5 amps to run this scalder. It's a rotary scalder, so that's what we'll be running as the motor. And then also the chicken picker here, which defeathers the bird. I'll be coming off my main panel here, and I'm digging a trench right now along the edge of the concrete that will be 18 inches in depth. That is also per code. The conduit needs to be buried 18 inches underground. It's not there yet, but I'll put a measuring tape on it before it's all said and done. Okay, so typically to run a 20-amp circuit, you would use a 12-gauge wire. In this case, because I'm going 75 feet away from the panel at my furthest receptacle, I'm gonna have a voltage drop of 3.73 volts. So I'm upping it to a 10-gauge wire so that we can not have any restriction on our working load and what we're drawing. Now, because this is an outdoor application in wet conditions, I'm running 10-gauge THHN wire that's got an insulation rating for wet and outdoor conditions. As far as the non-metallic rigid PVC conduit that I'll be using, it's Schedule 40, 3/4 inch diameter. So as you can tell, I kind of nerd out a little bit when it comes to electrical work. I really enjoy it, and for me, it's great to take a break from the carpentry and the woodwork that I've been doing for the past 2 months, building the chicken tractors and then the next brooder box that I did behind me. So it's nice to put the saw, the table saw, the tape measure away for a while and focus on doing some electrical work. I really enjoy this type of work. And I get kind of nerdy when it comes to numbers and the code requirements and all that. So I'm gonna enjoy this, but I do need to get back to work here digging this trench. I'll try to get some video footage of that for you guys and just keep you in the loop and include you in this project. Okay guys, I got my trench dug to 18 inches all the way around corners of the concrete and everything. I did run into a few problems here at the end with the root, so I had to break out the old hatchet and chop those out. So a little bit of a pain, but I've got it dug all the way around. Concrete. Russo is supervising, making sure I don't slack off. Okay, so the maximum amount of conductors that are allowed in a 3/4 inch non-metallic rigid PVC conduit for 10 gauge wire is 21. Maximum of 21, and then you are at your conduit fill capacity limitations per the NEC code. So we are running 6 wires, 6 conductors, so we are well under what we are allowed to run. Okay guys, it's the next day. I ran into a little bit of a snag yesterday. So I wanted to show you guys what I've done. We're picking up where we left off. And basically, I had to get some flex here. And the reason is because I need to jog slightly over to the left. And what I ended up doing was cutting some of the pole barn flashing away siding with my angle grinder right here. So basically, you can't have more than 360 degrees in one run. Okay, so that's 4 90-degree angles that we've got going on. So I need to pull the wire to a stopping midway point. So what I've done is I cut it off just above ground level here, glued the junk out of it, or cemented the junk out of it, and then put this little piece of flex, cut the siding and put a little piece of flex because I want minimal angles here, minimal bends. So I think what I'm gonna do at this point, because I've got so many, bends in this one run, and it is a long pull, this is. So I think I'm gonna stop here and I'm gonna do a wire pull on it. Okay guys, I ran into a major snag in the electrical job. And so I just wanted to come and show you what I've redone. I've had to redo it. I'm in a super hurry, I'm way behind schedule. So I haven't been able to film everything, but I just wanted to show you guys where I'm at right now in this process. So as you can see here, I had to redo my underground conduit with 1.5 inches instead of 3/4. And then I also decided to run 7 wires instead of 6, 7 conductors. Just because I want this to be, up to code, and I want it to be right. So I'm running 2 separate grounds for each circuit. Originally I wasn't going to do that, but I thought about it and I want to do it right the first time so I never have to do it again. I went larger on this conduit, one because I was having trouble pulling it, but it wasn't the actual conduit, it was my fish tape. Well, I actually think it was a little bit of both. So I went wider on this conduit to 1.5 inches diameter, Schedule 40, still rigid PVC under, and I did it with 360-degree bends and covered it back up. For the most part, it's still open down here towards my panel where I need to hook it up. So basically, it's got 490 bends, and then I did this Carflex bit here. I cut away this panel, I showed you guys that, and then I reduced it from 1.5 inches to 1 inch. So this is 1 inch rigid PVC conduit that I'm running up and over. There's a 90 sweep to a junction box. Below that junction box here, you can see I have my fish tape. Below this junction box here, I've got a receptacle. That'll be GFCI. And then right there where I have an R written on the post will be another receptacle. And that receptacle there will power the chicken picker. This one here is for the rotary scalder. This rotary draws 5 amps. So 2 20 amp circuits. My other one, my third receptacle, or my third box, total of 4 receptacles, I'm going to run off of this, and then I'll do a 45 here at the top, come down, Carflex this corner here, and then I will run it down here where I have it marked as a 4-way receptacle. So, and that will power our scale and also the vacuum packet right here. So it's been a tremendous amount of work to just get the electrical up and going, get it up to code, make sure I'm meeting all the requirements, and of course, you know, I've learned some hard lessons here along the way, but we'll chalk it up to experience, and I'm better for it now. So I wanted to share kind of some of my mistakes on the first go. It did cost me a little bit to go back and redo all this in 1.5 inch diameter. I should have done it the first time. I didn't. I was trying to get away with it because I didn't want to use size reducers into the boxes. And so I ended up having to get a step bit to be able to drill out the knockouts the rest of the way. So that step bit alone, right there for a Milwaukee step bit, I believe it goes to 1 3/8. $80 for that thing, $80. So when I'm done with this step bit, I'm gonna put it in like a gold frame or something like that. That's correct. $124 volts. Looks good. 124 volts at the furthest receptacle. Okay guys, as you can see, this was a long and arduous project, but everything is up to code, up to snuff. I got it centered right there on the pole. So we got 2 receptacles, 4 plugs here, and then 2 on this one, 2 on that one. Both circuits are working correctly. And if I move this ladder out of the way, I've already got the chicken picker plugged in. This is on its own circuit. So if we flip the switch, I'll call that success. We've got power and electricity on the furthest side of the pole barn, furthest away from the panel. So super convenient infrastructure for future processing and any other projects that we might have. You guys, I'm tired. This took way longer than it should have with all of the chores and extra stuff that I've had going on the side that didn't have anything to do with this project. So thank you so much for watching, and I'll see you in the next video.